Our next speaker is Jim Radford. Now, am I right, Jim, that you actually asked a question of another speaker? Yeah, that's very, very cheeky, yeah. So we're going to have to be careful in the panel session that they don't just ask each other questions. So you need to all get working on those thoughts to put to the panel. Jim is Associate Professor with Latrobe University. He's with the Department of Environment and Genetics and co-director of the Research Centre for Future Landscapes at the university. He leads the farm-scale natural capital accounting project. They're very big, long names for projects, Jim, which has developed tools and processes to generate farm-scale natural capital accounts for 50 farms across southeast Australia and relate measures of natural capital to biodiversity and ecosystem service provision. So my mind is reeling already with that introduction, Jim. You are going to demystify this all for us, and the topic of Jim's talk is farm-scale natural capital accounting. Welcome, Jim.
Thank you, Kerry. Thank you, Kerry. Hopefully we'll do some of that. So my job, firstly, thank you, and thanks for the invitation, Narelle, and the North Central CMA to speak here today. It's great to be here to see many familiar faces and many new faces, and there's a couple of our farmers from the project in the audience today, so this is a bit of a test for me. So my job is to drill down from that fantastic overview and introduction that Katie gave to say, what is natural capital? Why is it important at a farm scale, and how might we go about measuring it? So before we start, I'd also like to test the room, but in an old-fashioned way. No Mentimeter, no Slido, no social media stuff. So can you put your hand up if you think these images represent your current understanding of what we might be talking about when we talk about natural capital? So we've got some soil. Okay, we've got a wheat crop or a cereal crop here. Just keep your hand up if you think it's... wave it up like you're at a concert. You know. Okay, so that's not natural capital for some people. We've got a native grass pasture there. It's getting more like it. We've got a farm dam. That's the dam bit. Don't worry about the other bit there. That's the water resource there. Yeah, it's getting there. A pretty sick looking in this case, but scattered paddock tree. Yeah, some there, some coming down. Some replanted woodlot or it might be in a shelter belt or something like that, still sticking up there, mostly there. Some pollinators, we all love the pollinators. No honeybees there though. Got some native fauna represented by superb fairy wren, still there. And now some livestock in the paddock. I love the little chicken here that's hanging out with the... Okay, still there. Well, officially or formally, natural capital simply refers to all of the living and non-living natural resources. All those things basically that we saw on the slide, the plants, animals, soils, water, minerals that are present within a defined area, I'm leaning over a bit, that combine to produce a range of products and services that are of benefit or value, as Katie was saying, value to people. So we sometimes refer to them, or we can classify them in terms of whether they're renewable. So that is, and within the renewable class of natural capital resources, there's inexhaustible natural capital assets. These are things that we can't use or that are replaced at a rate that are faster than we use them. You know, solar energy, wind, tidal energy, that sort of thing, generally used for energy production, but also some of those critically important in a farming context as well. There's renewable but exhaustible natural capital assets. So these are biological assets that we harvest, and if we harvest them faster than they're regenerated by natural processes, they actually become exhaustible and so not renewable. So things like timber, kelp, fisheries, a lot of game species in different parts of the world as well. And then there's recoverable natural capital assets. So these do replenish, but at time scales that are longer than those renewable ones. So generally decades, centuries. Things like water resources, guano, the ozone layer. And then typically there's the non-renewable natural capital assets that are finite and only renew themselves over geological timescales. So effectively for us, they're non-renewable, fossil fuels, minerals in this class. And an interesting one And one that's probably the grey area is the bottom one, which refers to cultivated natural capital assets. So these are ecosystems, and it's what most of my talk will be about actually, ecosystems that are either generated or maintained by human intervention. Now the underlying foundational natural capital assets of soil and vegetation and air and water and that sort of thing is what these ecosystems are built upon. But they're basically our agricultural systems, pastures, crops, perennial crops. We can think about plantations, agroforestry, and even green urban spaces as being these cultivated natural capital assets. So the building blocks of natural capital are assets or stocks. So these are physical entities that can be quantified in terms of their extent. We can map them in terms of their length and width or volume in some cases for water and air and things like that. And we can assign a condition score or a condition assessment on that physical extent. So characteristics that determine the quality of that asset. And that condition determines the extent and the types of products and services that that natural capital asset provides. So the same asset can have a high condition if you're thinking about it in terms of the agricultural products that it might produce or services, but lower in terms of, for example, the biodiversity or the carbon sequestration services that it provides. Often they align, and Ange will talk about this next, and so you get a double benefit, but sometimes there is trade-offs involved. So assets are defined. Natural capital can be defined for a defined area. Most environmental economic accounting that's been done to date is at large spatial scales. So we might talk about the natural capital accounts for a country or a state or a region. What we've been doing in this project, I forgot these, is to drill down and define it for a farm. It can also be defined for the land and water that's under the management of a particular organisation. That might be a water management company, it might be a forestry company or a corporate farm and that sort of thing. So it can also be related to the governance structure. So in an agricultural context, this is there is a laser, yeah. Our diagrammatic representation of a typical farm that's doing everything, bit of mixed grazing, cropping, perennial vineyards, everything in there. The natural capital includes both the naturally occurring ecosystems, native grasslands or woodlands, forests, whatever might be on the property, as well as in both their sort of natural or least disturbed state, right through to a disturbed state, plus also those ecosystems that have been established and maintained by humans I was referring to before, those cultivated ecosystems. And these can be comprised either partly or entirely of non-native plant species. So this is things like crops, pastures, shelter belts in some cases. So a key point I want to drive home is that natural capital does not equate one-to-one with nativeness or even naturalness. Okay, it's about the ecosystem assets that are present on a farm. So we might talk about wetlands or woodlands or pastures or perennial crops that have that defined spatial extent and an associated set of condition attributes. And they produce, as I said, a range of goods and services. So in this diagrammatic representation, we have the typical things that we think about in terms of the soil and the water resources that are the underlying foundation of that provide the base and the nutrients and the substrate for growing the plants that support agricultural systems, the pastures, the crops, trees, what have you. There's also either shelter belts that might provide a microclimate regulation service to improve growing conditions for crops or trees, but also improve the microclimate for livestock. And that also might provide habitat for beneficial invertebrates that provide pollination, waste decomposition, pest control services. They also may provide some disservices. We have to acknowledge that in some cases that natural capital might be harbour for pests in an agricultural context. So they're all services that benefit the producer directly, either through reducing their need for inputs or increasing the efficiency of their production. So there's a private benefit or a benefit for production being derived from those natural capital assets on the farm. And all those assets that I've just talked about are completely invisible in a traditional accounting system built based on dollars only. We talk about infrastructure, we talk about the offtake, the products and the land value. The underlying system that supports the agricultural production on the farm is invisible. So what we're trying to do in natural capital accounting is, in a biophysical sense, put those assets on the books. There's also a whole range of services that are of benefit to society more broadly. So we can think about bits of native vegetation that might be on a farm that provide habitat for wildlife and conserve biodiversity, draw down and store carbon, provide protection of waterways that reduces leaching and soil erosion, better catchment, water health in the catchment and so forth. These are often of benefit to the farmer as well, but more importantly, they're of broader benefit to society. And so these are sort of public good benefits. And often there is overlap, there's joint benefits where both of those sectors get benefit from those assets. So if nothing else from my talk today, this is the diagram that I want to stick in your memory, that we've got a range of natural capital assets on a farm, providing a range of services and goods that are of benefit to the farmer, the producer well, not in one corner, but alongside that, a whole range of public service benefits. And in a broad sense, a policy sense, this is my preaching, is that society more broadly has a role to play in supporting the provision or the supply of those natural capital assets on farm. That's the policy problem. So, a related but distinct concept to natural capital is that of biodiversity. So biodiversity is the variety of all forms of life on Earth, from genes to species to ecosystems, and their interactions that actually drive a lot of those ecosystem services we're talking about. Biodiversity is a bit of a subset of natural capital, if you like. There's a close relationship, but natural capital also includes abiotic factors and their interaction. So it's not one and the same thing. We sometimes think of natural capital equals nature equals biodiversity. It's not quite the same thing, but they are interdependent. And as everybody knows, we are in a biodiversity crisis. This is my preaching part. Rates of species extinction are 100 to 1,000 times greater than the background rate. That is the non-anthropogenically caused rate of extinction over geological timescales. We have ecosystems collapsing all around us. A recent assessment suggests that 18 of the 20-odd broad ecosystem types in Australia are undergoing significant collapse at the moment. We're experiencing the great thinning of wildlife. They might still have species out there, but their density and their distribution is thinning, it's reducing. Numbers of threatened species continue to climb on our Threatened Species Act, and that's the ones that we can list. And indices of the abundance of species and their numbers continue to plummet. In my lifetime, globally there's 69% fewer animals in terms of their population numbers on this planet than when I was born in 1969. Now, the extent to which biodiversity can coexist with agriculture will have a large bearing on on conservation outcomes globally and in Australia. And this is because many species and many ecosystems occur in the same areas that we like to farm, because they're more productive and they have a lot of assets that are valuable for both farming and biodiversity. So, for example, in southeastern Australia, 51 species or subspecies of woodland birds that are threatened or in significant serious decline occur mostly in agricultural landscapes and on farmland. So to restore ecosystems and biodiversity loss, we need new ways to value, measure and manage biodiversity in ag landscapes. And as we've just heard fantastically from Katie, Australian farmers are or will be under increasing pressure from international and domestic markets and their supply chains to report on their environmental performance and demonstrate their environmental and sustainability credentials. And so, one response to this is natural capital accounting, or environmental economic accounting. And it's often been promoted as a tool for quantifying and valuing natural capital assets and reporting on environmental performance. So like traditional economic accounting, natural capital accounting follows a standardised set of methods to measure the natural capital assets in a defined area. We follow the UN system of environmental economic accounting, ecosystem assets guidelines, for a particular area for a particular point in time, and then to estimate the contributions that makes to the economy and to society through their products and services. We prepare them in biophysical terms, so defining the extent and condition of the assets rather than the monetary value, because it's those biophysical terms that the farmers and the land managers make their decisions on about in terms of their management responses. How can they respond to the extent and condition of the different assets on a property? In our project, we generated these specifically at the farm or enterprise scale so that we could provide visibility of the condition of the underlying natural asset base. And we suggest that these complement, should be sitting alongside financial assets to give visibility to the value of those natural capital assets, and to explore and explain whether the financial performance of the farm is either impacting upon or benefiting from the underlying natural capital asset base, and how those are interacting. So now I want to talk about how we went about doing this and measuring it. Hopefully that's given some idea about what natural capital is and why it's important, and how the hell might we measure it. So our farm-scale natural capital accounting project, we developed natural capital accounts for 50 farms from the New England tablelands through the Midlands of Tassie. These were pretty typical mixed cropping grazing farms. We went to span the spectrum from entirely cropping to entirely grazing, but we didn't include horticulture, dairy, or anything that were based on pretty standard livestock and cereal and pulse cropping systems. And it's great to see, I think three of our farmers in the room today. Range of size from a couple of hundred hectares to several thousand hectares. So quite varied. Okay. I reckon this rivals your horrendogam, Katie. Don't even try to get at the detail. This slide is here to remind me that we didn't just pull these condition states out of the air, that they were based on a set of underlying state and transition models. So depending on what the pre-development or the pre-European native vegetation type was in the landscape or on the farm, whether it was a grassland, a woodland or a forest, we devised a set of state and transition models which described the degree of divergence or a degree of disturbance from a reference condition state right the way through to highly modified states. So we could essentially allocate any patch of land on a farm to whether it was a woodland or a derived grassland that was used for livestock grazing, pasture, whether it was replanted with exotic or native vegetation, and so forth. So there is a basis to it. So using a combination of remote sensed imagery, machine learning, ground cover data, and farmer management input data, so their farm paddock maps and other management data that was available, we created a first iteration map of the ecosystem states and their condition that were present on a farm at around about paddock level, sometimes sub-paddock level, so a paddock could be divided into smaller ecosystem management units. So this was our first iteration of the natural capital asset base on a farm. We then sent ecologists out into the field to ground truth that first estimation. So they took a range of rapid assessments of canopy cover, shrub diversity and cover, ground cover composition, litter, bare ground, erosion risk and things like that, to ground truth the data we were getting from space and to assign those ecosystem condition states to a particular area. We then imputed to those areas we didn't visit based on similarities in those remote sensed assets, rolled this all up so that we had an ecosystem asset register, which was basically allocating every hectare on your farm to one or more of these, just to one of these ecosystem condition states. And from that, we generated a set of accounts. Oh, point it there. So the farm scale natural capital accounts, importantly, are farm scale, they're data driven, they're time stamped, they're robust and they're repeatable. So one is not enough. The real value comes when the repeat assessment is done and we can see changes in the extent and condition of the different natural capital assets that are underlying it. They contain verifiable information on the extent and the condition of the natural capital assets, the soil, vegetation, biodiversity, the ecosystem services that those assets provide, things like forage, carbon sequestration, pollination, soil regulation, biodiversity habitat, shade and shelter, and measures of environmental performance such as such as greenhouse gas emissions, rainfall use efficiency, waste pollution and so forth. So I'm going to whiz through what this might look like in an account. Joe, Graham and Claire can attest that there's a lot of detail in them. Each farmer gets it's about an 80-page account, but there's a lot of maps and tables in that as well. It's not dense text. So firstly, the basis of it is the spatial distribution of these different natural capital asset types. So we can see in this one, and we can't because the laser doesn't work, we've got some Horticulture, olive groves in the stippling through the middle there. We've got irrigated cropping, we've got dryland cropping, we've got some grasslands in the blue that are used for grazing, and we've got some woodlands in the green of different condition states represented by the different colours, shades of green. And that will vary from farm to farm, the number of different types and their extent. This is the basis of it. It's the aerial extent, the amount of the different condition states. So the state is the ecosystem state in the middle there. It represents a whole bunch of condition attributes that's wrapped up in terms of the amount per farm. And we give an ecological condition weighting to that so that we can have an overall condition score that's analogous to an accounting for nature sort of E-condition, and the proportion of the farm that each of those states are in. So when this is reassessed in 5 years' time, we'll be able to look at changes, shifts, whether you're drawing down on particular assets or whether you're reinvesting to improve your natural capital in certain things, just like you do on a bank account. We did a whole bunch of other things. We looked at the birds, so we produced some biodiversity accounts. This is the same farm. This is oh, you can't even see it. It's right down here. The amount of the species richness for all birds in different parts of the farm, depending on the underlying asset base and some local areas. We modelled this for woodland birds, for grassland birds, for open tolerant birds and things like that. The point being, we can then wrap this up again into an account-based thing, which is the area of different habitat value for woodland birds in this case. And on this farm, there was about 380 hectares, roughly about 5 or 6% of the farm that we considered to be good or very good habitat for woodland birds. We did the same thing for plants. We did a similar thing for invertebrates and the ecosystem services that they provide, whether that's waste decomposition, pollination, pest predation. And again, what proportion of the farm has, poor through to outstanding habitat and therefore probably providing those services to different extents. There's a whole range of there's some indices relating to soil condition and soil regulation. We use ground cover until the soil scientists can give us a good, easy to measure, quick and broad scale measure of soil condition. Ground cover continues to be a good surrogate for a lot of things. So we used mean minimum ground cover over the last 5 years and mean ground cover, and also what proportion of the farm always remained above 70% ground cover, which is a threshold for soil erosion risk. And again, we can classify that in terms of statistics and areas to provide a quantification of these assets at farm scale. And importantly, we provide the spatial explicit map of this so that a farmer can say, oh, over here I've got higher risk or lower risk of soil erosion, or my ground cover's better or worse. And that might then be able to relate to the different management practices that they're employing in those areas. A slightly new thing is we provide a map of the shade, which is important for livestock production across the farm. So what proportion of the farm gets shade? We used a point in time, 3 p.m. on the summer equinox, hottest day of the year, allegedly, in the mid-afternoon to see what sort of shade provision is provided on the farm. And likewise, what sort of shelter do you get from hot northerly winds in summer or cold southwesterly winds in winter? Again, to what level of extent of climate micro-regulation are you getting? These are informed by work done by CSIRO in a similar system around the extent of micro-regulation related to the height of the vegetation and their composition. So again, we can quantify this in terms of the area of the property that gets some level of microclimate regulation and ecoservice provision. We looked at soil carbon through partners at Downforce Technologies, provide estimates of soil carbon in the top 30 centimetres over each of the last 5 years, this is estimate from space, and estimates of greenhouse gas emissions. So Katie introduced these notions of scope 1, 2, 3. We also split it into geospheric, whether it's derived from fossil fuels, or biospheric, whether it's from your livestock and decomposition of crop residue, to get and balance that against the sequestration that's from your woody vegetation, both above and below ground, and to get a final balance as to whether that farm overall is a net carbon emitter or a net carbon sequester for this particular period in time. And a whole range of other performance measures such as waste pollution, the amount of waste produced, the amount of water pollution, the efficiency with which some of the nutrients are being used by the farm, nitrogen, phosphorus, lime. This is all dependent on good quality farmer input, this stuff. So in summary, the benefits we think are that farm-scale natural capital accounts can play a critical role in environmental performance reporting. They provide a direct line of sight between the assets and the management, so they can hopefully help inform farm management decisions. They increase that transparency that we're looking for in the supply chain, so that actors higher in the supply chain can see that the environmental performance of a particular enterprise. They reduce risk for financial stakeholders, lenders, investors, insurers and the like. And they can provide an access point, jumping off point into some of the ecosystem service markets and biodiversity markets that are coming on stream. So the accounts provide this verifiable information on the environmental performance of farm businesses, hopefully overcoming some of the problems associated with greenwashing and providing a valuable tool for farmers and landholders. So I'm pretty sure I've gone over time, so thanks for listening. And I'm not sure if we've got time for questions, but obviously in the panel and all day. Thank you.
Someone's put the fear of God into these speakers. They're all doing very well, so it's making my job easy. We do have time for some questions, and it was really interesting. We employ accountants to do our finances, and now it seems like there's a whole new profession emerging to do a different type of accounting. Have you actually assessed how much that investment will be to do that type of work on a farm? Is that something you can talk about, Jim?
The cost?
Yeah.
Well, it is, but like anything when it's new, it's a lot more expensive now to do it than when we continue to develop the processes and that sort of thing. So what I just showed with a lot of the biodiversity survey work is not part of developing an account going forward. So we have estimates that, it's probably in the tens of thousands of dollars per farm to develop an account of that level of detail. The first one, repeat ones will be less. But as we refine methods, most of that cost, or a lot of that cost, is in the on-ground component to assess the condition states. So if we can come up with or develop better methods to have a better first iteration of that ecosystem condition state, that'll bring the price down. And we've got research projects that are looking to do that, to better harness the Earth observation tools that are out there, so the remote sense data that's out there, to deploy better machine learning, artificial intelligence to try and define those ecosystem states, and to better integrate farmer-provided data and sensor data into that. So at the moment, it is costly. Well, I don't know if it's costly actually. It's probably between, depending on the size and the complexity of the farm, between $10,000, $20,000, $30,000 per farm to set it up. But I am confident that will come down, and we're sort of aiming for sort of $5,000 per farm for an assessment would be getting to that. It's not unrealistic.
G'day, Jim. Paul Sinclair from the Australian Conservation Foundation. I was interested in what you think needs to happen to increase the number of farms that are involved in assessing natural capital.
Well, I suppose the value in it. At the moment, I still think there's a burden on, or a responsibility on us to show the value of why you might want to invest in it, and why you might want to, invest in the time and dollars to do it. But also, I don't think the responsibility should be carried entirely, the financial responsibility entirely by the farmer. So there's a lot of benefit to the supply chain in this. So Katie was talking about, the big corporations have to report on their climate-related disclosure. They need to step up to the mark and invest in where they're gaining their products from, their source, their scope 3, if you like, emissions and nature-related emissions, and carry some of the responsibility for investment in this sort of data collection. Whether it's this is one of a number of methods or approaches that are out there, and we think it's a good one, but it's not by any means the only one. And we're doing a lot of work on harmonising these different things as well, these different approaches. But the bottom line is, they're getting benefit out of it by being able to report on their climate and nature-related disclosures, so they need to start to invest in the data collection side of it as well.
We have a question in the centre.
Thanks, Jim. A slightly technical question. If you're comparing accounts between time periods and you're looking at, say, attributing, say, a particular management practice to sort of an increase in condition or declining condition. How will you attribute it to actual management practice as opposed to sort of more larger scale kind of drivers of change? So, I mean, that stat you said that we've got 18 of our 20 ecosystems in a state of collapse at the moment. It's pretty alarming. I mean, that's driven clearly by a whole lot of things, probably one's climate change to on top of it. So these larger pressures that are impacting natural capital on farms, how do you tease the two apart?
Yeah. Well, it's a good question. Difficult question. So I suppose that the accounts are also, just to go back a step, the accounts aren't designed to test the effect of different management approaches, I suppose. They're an outcomes-based tool to say, well, this has been the effect of the cumulative impact of whatever's happening in that particular area. But decoupling, the on-farm management actions from broader landscape scale influences and climate influences is a bit of a wicked problem. It is a difficult one. I think, having reference points in the landscape of similar systems that are less disturbed or even on the same farm is one approach, but it's I don't. To be honest, Sophie, I don't have an answer to that. It is one that we need to be aware of in terms of particularly the climate influences, but also landscape influence. So, for example, a farmer might be doing all they can in their landscape to improve connectivity, habitat resilience, and yet not see a biodiversity response in that. So, I suppose just thinking about this on the run, one of the things that we are also wanting to do for a lot of these metrics is devise regional benchmarks or regional standards for the metrics so that the expectation can be regionally contextualised. Now, it's not quite the same thing as decoupling or separating out the effects of broader scale influences and climate, but at least it's putting the indices and the indicators in a regional context. So we haven't done that piece of work yet. It's one we're looking for a funder for. But I think that's an important next step in contextualising the values for the landholders.
We've got a question from the online. So, given some areas do not generate an income, for example, woodlands, remnant woodlands, are farms with a higher proportion of such areas being penalised?
No. Well, I'd also contest the basis of that they don't generate income. They do, I suspect they would contribute to the income through some of those ecosystem services. They're not being penalised in any sense. I mean, that the woodland areas will contribute to a range of the natural capital assets that will be reflected. I mean, the accounts are just a transparent sort of representation of what's on a farm. There's no value judgment necessarily on that composition of the farm to begin with. So it's then up to those that are using the accounts as to what value, I suppose, they want to assign to different assets that are present. So some will be valuable from a biodiversity perspective, some will be valuable from a production perspective, and I suspect that the interplay between the two, is something we need to continue to explore. And so, what contribution do the different assets have on production? Without giving Angie's thunder away. But also, the other point to that is that if we do value the role that those woodlands play for carbon sequestration, for biodiversity conservation, for other services, then that's where other mechanisms and other other markets need to come into play to help to pay for the provision and the maintenance of those assets on a farm if they're not directly, a large contributor to the on-farm income. Does that make sense?
That's great. Thank you.